Welcome to the walkthrough of Assignment 2A in my courses on Scalable Microservices in the spring of 2024. The purpose of the first part of this assignment is to deepen your understanding of how to develop multiple synchronous microservices using Spring WebMVC, the Eureka Discovery Service, the Spring Cloud Gateway, the Retrofit, type-safe client API, and the Java Persistence API, or JPA. In this assignment, you'll apply JPA to create a database that stores information about movies and supports various SQL queries, as well as apply Retrofit to create several type-safe client APIs that access database and timer microservices via an API gateway. The code you write for this assignment doesn't have a GUI and runs as a Spring application with an integration test program. Please feel free to use this test program to help debug your solution. The following resources may be helpful in completing this assignment. A tutorial on the Java Persistence API appears here. A tutorial on Retrofit appears here. And I also recommend you use ChatGPT to help learn and code these various APIs. Naturally, we'll cover this material in class, which will be available in my YouTube playlist. The Movies microservice is packaged as a project using IntelliJ. This app is written in Java and demonstrates various Spring WebMVC and Java concurrency and persistence features. For the purposes of Assignment 2A, however, you need to be aware of the following folders. Client, which contains a client test driver program containing proxy skeletons you need to fill in, as described below, and database, which contains the database microservice skeletons you'll also need to fill in, as described below. In addition, you'll need to tweak the synchronous MoviesEX microservice implementation from Assignment 1C, which is found in these folders. MoviesEX, which contains the skeletons you need to fill in, as described below, and Movies Source Test, which is a set of unit tests that exercise the features you're implementing to motivate and evaluate whether you've correctly satisfied this earlier assignment's requirements. To compile all this code, you need to use the provided IntelliJ project. You can test the MoviesEX portion of this project by clicking the green arrow next to the MoviesEX test dropdown menu in the IntelliJ IDE. However, you need to do a bit more to test the database portion, which will involve first clicking on the green arrow next to the Run Microservices dropdown menu, followed by clicking on the green arrow next to the Database Client Driver dropdown menu. You'll need to modify several files containing skeleton Java code by completing the to-do you fill in here task to provide a working solution. Don't change the overall structure of this skeleton. Just fill in the to-do tasks. And whatever you do, do not delete the to-do markers or your submission will not be reviewed. In particular, you'll need to finish implementing the to-do task for this assignment in the following files and folders. In the client folder, where there are several subfolders where you need to complete the to-do tasks in the various fields and methods to implement a type-safe client using Retrofit. The database folder and subfolders where you need to complete the to-do tasks in various fields and methods of the database service that uses the Java Persistence API together with Java sequential and parallel streams to return lists of objects containing information about movies. And you'll also need to complete the to-do tasks in factory methods in several server beans and client beans files that can be injected into Java classes using the Spring auto-wired annotation. As usual, your solution should strive to use few, if any, loops or if-else statements in this assignment, and instead use Java functional programming features, including lambda expressions, method references, sequential and parallel stream aggregate operations, and so on, as well as Java concurrency mechanisms. Your solution will be considered correct if it passes all the unit tests, is commented thoroughly, and addresses my review comments. Solutions that are not commented thoroughly will not be reviewed. Skeleton code for this assignment is available here in my GitHub repository. Please pull this skeleton code into your repository, read it carefully, and complete the to-do markers. There are black box integration tests here that increase our collective confidence that your implementation is working as expected. As usual, testing only demonstrates the presence of bugs and not their absence, so please don't rely solely on the unit test to detect problems in your code. Assignment 2A is designed to deepen your understanding of developing multiple synchronous microservices using Spring WebMVC, the Eureka Discovery Service, the Spring Cloud Gateway, the Retrofit type-safe client API, and the Java Persistence API. The skeletons and tests are quite extensive, though you don't need to understand them all to complete your solution. However, this assignment is much more complicated than Assignment 1C. There's lots more moving parts, so please start early and ask questions in class, office hours, and on the discussion forums to ensure you understand this assignment and complete it successfully. Now that we've walked through the specifications, let's take a look at the skeletons you need to implement for Assignment 2A. The first thing you need to do is go into the MoviesEX module, and you're going to have to add the appropriate features back here from your Assignment 1C. In particular, you're going to have to come in and add in the client portion down here, the movies sync proxy, you need to fill in the blanks there. This is largely going to be cut and paste from what you had from your code. In fact, most of this is cut and paste with a couple of minor exceptions. There was a number of people who had some problems with not putting the checks in their microservice controller to do the decoding of the incoming regular expressions. And previously our test didn't check for that. So we've added checks for that. So make sure that you integrate that logic here and make sure that you do the appropriate decoding using the web utils decode query methods, both the singular one and the plural one. So make sure you add that here. Then make sure you take that code out of the service so you won't have to do the service stuff. And almost everything here will be the same, assuming again that you did it correctly for assignment 1C. The one difference is this method down here, convert movie matches. I've changed it so now there's just a call to one helper method, which you can probably guess where that comes from, to convert the list of future movies into a list of movies. And that's just because the code there before was unnecessarily verbose. So go take a look at where you think this should be. It should be pretty obvious based on what you used before, and you can simplify the code. But everything else should be pretty much the same, and make sure that you address all the comments and frequently made mistakes. So that's just kind of cleanup from assignment 1. Now that we've talked about the movies EX module and the tests and so forth, let's go ahead and talk about what you'll need to do for assignment 2A that's new. So the first thing you're going to need to do is go into the database module and go down into server and take a look at the database controller. I have provided you the database controller logic. So it's got all the pieces there. It's got the appropriate get mappings for a couple of the methods, and it also has a post mapping for one of the methods. So all that stuff's been put there. You don't have to worry about that. What you will need to do, however, is you're going to need to be able to do the database repository and the database service. So let's talk about the database repository first. These are a couple of methods you'll have to do to implement the logic described in the comments. So the first one, you're going to have to implement a method that will basically return a list of movie objects that contain the query that's passed in as a parameter, ignoring case. So you'll have to figure out how to write that code. And I recommend you either take a look at the EX4 example we looked at, which was the zippy quote example, and or use ChatGPT to see if you can get it to help you write that code. Likewise, you'll also have to write another query method here that will return a list of all movie objects in the database sorted in ascending order by ID, which of course is the movie title. Again, this is something that ChatGPT may be able to help you with, so that should give you some hints. Once you've got those methods implemented, and they're not methods you have to implement, you just have to define them because it uses the special features of the JPA. Then what you're going to do is come over here and you're going to use these methods in the service. So the getMovies method is going to end up basically calling the method here that returns the items in ascending order by ID. So that's just a straightforward call. This method here, the query, will end up calling this method that you have to write, and it's just a straight forwarding and pass through. But then the third method, the search method, is something you're going to have to do, and it's a little subtle. You're going to have to use Java parallel streams and that JPA method you created to find all the movies whose ID matches the list of queries and return them as a sorted list of movie objects that contain no duplicates. And I recommend you split it up into two parts. The first part will use parallel streams, and you should take a look at the EX4 example for the Zippy application, where we had the Zippy service, which used flat map and a call to the underlying generated database repository method, and did some other magic stuff that you'll have to think about. And then what you'll also need to do is then store that in a list of results, and then use that list of results to sort it and deduplicate it and then return the list. So that'll be a little bit of thinking on your part. You might be able to use ChatGPT to help you there. I'm not sure if it'll be smart enough to do that on its own though. So that's something you'll have to do. And that's basically what you have to do for the database portion. Then the last piece of the puzzle here is the client part. And this is going to be real fun because this is going to give you a chance also to hopefully use some ChatGPT to help you out. So over here, we've got a database client driver, and that's of course what gets run when you run the tests, as we'll talk about shortly. And this is going to go ahead and run the movie tests and then print the results. And if you look here at the test client, that's found over here. That's this database client. And you can see it's got some auto-wired pieces and this should be not database, not recommender client, it should be database client. And we also want to change this to database client. That's just a little minor mistake in the documentation. So these are the couple of auto-wired proxies, and you're going to have to implement the proxies. There is a boatload of black box testing methods down here. You don't have to know or think too much about how they work. They're just going to test your code, assuming you get it working correctly. And what you're going to have to do is you're going to have to come along here and do the following things. First, you're going to have to implement the database API, and this is going to use Retrofit format. And the way I recommend you do this is shown in the video I created recently and posted on my channel, where I show how I can use ChatGPT to take the methods that are defined in the database controller, the guys that are defined over here, and basically convert them into the corresponding Retrofit APIs using all the techniques that are described in that video. So if you watch that video, you can probably do something very similar using ChatGPT, and I recommend you do that, or you can do it yourself by hand, whichever one works best. So you'll define the database API, and then you'll also define the database sync proxy. And once again, this is something that ChatGPT can probably help you with. You're going to have to define pretty much boilerplate code. It's pretty simple. It's very canonical that will call down into the appropriate methods from the database API. So you generate that, and that's the retrofit part, and then you have to write all the methods that do these calls, and there's 6 of them. When implementing the database sync proxy methods, I recommend you take a careful look at the call utils utility class shown here. The execute call method is something that will make your code much simpler to implement rather than having to write all of this complicated logic each time in the implementation of the methods in database sync proxy. So that's what you'll do for the database access. And then over here, you'll do the same thing for the timer service. So once again, you'll come over to the timer service. You take a look at the timer service. If you click down here, you can see it's got a controller. And really all you care about here is the method called get timings. So you have the get timings method. That's the only one you need to define in your timer API. And you'll define that using the appropriate retrofit syntax. That'll then be used to auto-generate the timer API. We'll look at how you do that in a second. And then you'll have to write the timer sync proxy, and you'll just write the code here. And that, again, is something that ChatGPT can probably help you with, which is cool. Now, the last piece of the puzzle for the client is coming over here and filling in the client beans. And there's 3 things you're going to have to do. First, you're going to have to write the code here that will initialize this REST template bean so that it will know how to connect to the API gateway URL. So you can go over here and find where that is because it's defined here, but you'll have to know how to wire those things together or put the methods in there to do the call. You can look at my other examples to see how to do that. And then you're going to have to fill in the code for doing the creation of the database API and the timer API. These are the guys over here that are written using Retrofit. And once again, ChatGPT is going to be your friend because you can kind of ask it to do that stuff. And there's a couple of hints here. You want to use the JSON converter factory for the database API, but the scalars converter factory for the timing API. And that's because this returns lists and they have to be encoded with JSON, whereas this just returns a Java string. So you don't have to do anything fancy. You can just use basically the scalars converter. So you'll have to figure out how to write that code. The code down here is already done for you, but you'll have to fill in the blanks there. I strongly recommend, again, as much as possible, try to use the automated tools from ChatGPT to write this code. You're also welcome to do it the old-fashioned way, but at least in my experience, it's a lot faster once you know how to send the commands, the prompts to ChatGPT to do this stuff. So that's basically it. And once you've got all this stuff running, then you'll test it in various ways, and we will talk about that next. Now that we've walked through the specification and the skeletons, let's take a look at how to run the tests. First thing you need to do is rerun the tests for the Movies EX module, which is what was the basis of the last part of Assignment 1, Assignment 1C. We've made a few minor tweaks to the test to test things more thoroughly and also to improve some of the methods to make them more concise and less verbose and duplicative. So what you need to do here is go ahead and run the Movies-EX test here by clicking on the green arrow after you select that from the drop-down menu. As you can see, if all goes well and you've implemented the methods correctly, all the tests should be green. So please make sure you do that. If you don't integrate your code and update it, you'll lose points from assignment 2. So please make sure you have everything working properly from assignment 1C. Don't worry about the movies module, just the movies EX. So as you can see here, everything worked just fine. We're now going to show how to run the database set tests. And these are going to be a little bit different from running the other tests because you actually have to run the microservices first. So what you do is you go ahead and click on Run Microservices. If you take a look at the microservices, you can see we've got Eureka Database Application, Gateway Application, and Timer Application. So you go ahead and start those, and that'll take just a little bit to start up. What you can do once you click that is you can see that the various tabs will show up. So we'll start off by doing the Eureka application, then we'll follow that by running the database application. That takes a little bit longer to start up because it's got to initialize the database. After that gets up and running, we'll then launch the gateway application, and then finally we'll run the timer application. So let's just wait a moment while those different microservices start. So once all the microservices have started, then you want to go ahead and click on the database client driver, and you'll start that up. Naturally, you have to make sure all your other microservices are running before you try to run the database client driver. And what that will do is it will go ahead and send requests over to the gateway application, which in turn will use the Eureka microservice in order to be able to find out where the corresponding requests are going. And they're going to go both to the database application, database microservice, as well as the timer microservice or the timer application. And that's all kind of taking place underneath the hood, behind the scenes, by using the features that are available through the gateway, the API gateway mechanism, and Eureka, and so on. And if all goes well, then you should see the results looking something like this. So there'll be all the different things should return the appropriate number of movies, which are all tested by the actual test that we looked at. And you should get results that say one call to database search, one call to database searches, one call to database all movies, and it'll say how long it took to execute. Those execution times, of course, are received and managed by the timer microservice, which is running in the background. You don't actually have to write that, but you'll have to be able to interface with it by writing the appropriate controller methods that will forward and delegate to the timer service. So that's the end of the running of the tests. Make sure that all these things work properly. And as usual, go ahead and take a screenshot of these tests, and also, of course, take a screenshot of running the movies EX tests and include those in your GitLab repository when you push your solution.